Thanks. Okay, well, hello everyone and welcome to the DataSHIELD Beginners Workshop for the Athlete Consortium members. I'm Alex Westerberg and I'll be presenting for the first hour of the workshop or thereabouts. And my colleague Dimitri Avram will be presenting for the second half. Thank you, Rodney, for helping to set this up. So, this is a table of the approximate structure of today. So I'll be continuing this slideshow with some diagrams and animations of what DataSHIELD is to help you understand it and how it works. And then we'll move on to the actual demonstration itself, which uses a virtual machine. That's VM there. And then from oh, sorry, the times are actually a bit wrong here, but from about 20 minutes time onwards, we'll be slowly going through a script I created earlier, doing various things like logging in, commands, summary statistics, and so on. So we'll go nice and slowly, and at any point, feel free to drop questions in the chat. We'll have quite a lot of time for questions at the end, hopefully longer than 20 minutes. We'll see how it goes. So to get started, what is DataSHIELD? I always like to think about the sentence, which is a privacy-preserving federated analysis software. I'll get to those two terms in green and orange in a second. But making sure we know what it is and what it isn't. It is a way of analyzing sensitive data without providing direct access, but it isn't a data harmonization platform. That should have happened before you start analyzing it through DataSHIELD. If data isn't harmonized with itself, like between themselves, then the data custodian would have to be responsible for that, because the whole point is not being able to look at it yourself directly. Nor is it a graphical user interface analysis tool. It's done using the R language. So the privacy preserving part of that definition. So the functions that you think of running an R session on your computer, that's this side, they get sent, writing in specific DataSHIELD syntax and specific functions. That sends it through internet networks. And then we have the server computer, which actually has the sensitive data stored on it. Then whatever statistical commands run there. But another important stage before it comes back to you is the disclosure check. So every single statistical function we have in DataSHIELD has a disclosure check, which checks if you are doing something that will reveal individual level data or results that you shouldn't have access to. So based on the check, it will either be decided to be non-disclosive, in which case you can have the results, that's the green arrow chain, or if it is disclosive, then that will be blocked. Instead, you'll get an error message coming back to you as the output. And based on the error message, you can change what you're doing to hopefully get results of the function without an error. And the federated analysis part of the definition, federated meaning spread out around the world. So particularly consortia like Athlete studying data all around Europe. So there'll be connections that you make from your analysis PC out to servers in multiple different locations. The data is stored on these servers, and so there's no risk of it being intercepted while being transmitted. Also, in the case of very large databases, that you're trying to study, there isn't that whole aspect of waiting for large data sets to transmit over slow connections. You are only transmitting very light summary statistics, so it's much faster. So what we've got here on this slide is an animation of how DataSHIELD works. So the various bits of the script and where each one goes, etc. So it helps me certainly understand how DataSHIELD works a bit better. So that flashing logo there, that's me, the user in Great Britain. And then we'll have a look in that orange box is going to be things going on in my computer. And then the blue box is things going on in the data server computer. Obviously there's multiple data servers, but we'll just look at one for now. So that's me, the stick figure. And I will have login details of the studies provided to me. So we'll enter those into a data frame and use a command to transmit them. And that will make sure the data server knows who I am, and then open an R environment for me to start studying inside. And that connection between the two computers is the DataSHIELD session. So then I'll come up with some commands like what is the mean of this data that will be sent using a command and read by the R environment in the server computer. And then a result will be processed, in this case, a graph. And the graph gets sent back, assuming it has passed the checks of non-disclosure. Simultaneously, in all these other blue boxes, results will be generated, and then they too will be sent back. And then meta-analysis is generated from the combination of those results. So some functions in DataSHIELD tell you what's happening on each different server, and then the aggregated results of them all together. Others only let you look at the aggregated results. It depends on what you want, and you can use different DataSHIELD functions for different things. So that's the end of the animation. There are multiple kinds of analysis we can do with DataSHIELD, and it's also currently growing month to month. We're trying to do regular releases, and each major release generally sees new functions coming out for new statistical techniques that people have requested from us. So you can have a look on this wiki link. I'll be going to that later, so you can see what that is. But I'll just can I put it in the chat? No, I'll have to go to it later. In the course of this workshop, we won't have a go at all of them, but we will have a go at some of the most important ones. And then you'll have this link in the chat later to go to it and come up with other statistical commands you might want to try out for yourself. So how will this demonstration work? I provided a link to a VirtualBox a machine image earlier. However, due to some technical difficulties, I'm not sure how many of you will have actually managed to download the right one, as it only went live this morning. So what I will do instead is I will show you all the stages of how to set it up, and this recording will be available to you later to go back through it in case you didn't catch it in real time. And then that VirtualBox image will be perfect for you to have a go yourself and reinforce what you've learned from listening to us here today. So just to clarify some terminology, so VirtualBox is a program that runs on your computer and allows you to boot virtual machines. Virtual machine being a small computer that exists virtually and is operating within your computer. So it's taking your computer's processor and memory and other services of that sort, but it will behave entirely separately. So we can connect to it as if it's an internet server, as if it's a website. The particular virtual machine that you are directed down to download today will work as both the analysis session and the server, because we also have an Rstudio server running on it. If you downloaded R and Rstudio, that's good. That's a backup in case you're having troubles with your virtual machine. So I'll show you how to access the Rstudio server. I'm running a notebook for this demonstration, but if you're not familiar with notebooks and prefer R scripts, you can use that instead. I'll show you how to do that once I'm in. From there, we'll log into data and conduct analyses. And we're aiming for each chapter to last about 15 minutes. But as I said at the beginning, it might vary a little bit. And yeah, any questions you have along the way, post them in the Zoom chat, and my colleague Dimitri will keep an eye on them and bring any to my attention that need to be urgently addressed, and any that are more conceptual we'll try and answer in breaks and at the end. So it's time to go. I need to share a different window now. Screen. So, first step is to, well, obviously, if you haven't installed VirtualBox yet, then that would be a thing to do. But once VirtualBox is installed, it should look like this, although you wouldn't have as many things down the left-hand side as before. Oops. Don't know what that is, but anyway. So if you have nothing here, then you would go to File, then Import Appliance, and then on your local file system, you'd click this button to navigate to the .ova file that you will have downloaded from the link provided in advance of this workshop. And it will look like that if you've got logos enabled. So that's an OVA type file. And you will want the one called 2021-01-25, so that's the date today. I'm not going to do that because obviously I already have it imported. Once you click next and click through that, it will take maybe 2 or 3 minutes to actually import. Once you've gone through that, you will see one of these ready to go. The next thing you would do after that is go into Settings. So you can left click on it so it's blue and highlighted, and then Settings. And then you would navigate down to the Network tab on this left-hand side and check that Adapter 1 is NAT and Adapter 2 is Host-Only Adapter. So just to reiterate, if you're finding this a bit fast, it will be available later as a YouTube recording. The second check you should do is...
Yeah, how was it? Is it good?
Hello?
Either hyper or level.
Is that a question, sorry? I presume not. So the next thing, you need to set as settings is you go to File and then go down to Host Network Manager, and then you'll need to make sure this VirtualBox host only an Ethernet adapter is created, and that once you click on it and then go to the Adapter tab, it's got this IPv4 address and IPv4 network mask. If you have trouble remembering this, another source for it is to go to the DataSHIELD website and then to the wiki and then to the beginners hub, and there's a detailed installation guide there. And also DHCP server unchecked, so that needs to be blank. So assuming you did all that, then you can left click on the now configured virtual machine and click run. It doesn't say run here because I'm already running it for the purposes of the demo. So when it boots, it will look like this. So it's just a very basic computer, and you don't have to go in through this. Instead, we are going to go to this website here. So this is the website that you were directed to on the preparation materials for the workshop. And as well as the download image link, you will have various services attached to this virtual machine. So the important one here is the Rstudio Server. So I'll click on this. And it will launch, and you should be able to see an Rstudio, R Markdown file ready to go. So this contains lots of text describing what each stage is doing in case you're looking at this later and just want to read through instead of listen. And then in between them, there are these code chunks, each of which you can run individually.
Excuse me, can I ask a question?
Yes.
Is this image that you're showing now within the VM, or it is in your desktop?
Sorry, could you ask again?
So this image, this web browser that you're showing now, is this within the VMs that we just opened and downloaded, or this is in your local machine?
No, it is within the VM. You're right.
Oh, this is within the VM. Okay.
Because we are connecting to an IP address, and that
Okay.
IP address is stored within the VM. Yes, exactly. So to get to that, you will have to have your VM running. Yeah.
Oh, so basically you are using the browser on your computer to connect to the web server that is installed in the VM.
That's exactly it.
Okay. Do you have the database in the VM as well?
Yes, it's
Okay.
all stored there. Yeah.
So basically, once you run the VM, the server will be automatically running. You don't need to start the server yourself.
Yeah, exactly. It's all contained in one.
Okay, cool. Thank you.
No problem. So hopefully some of you managed to follow that, and hopefully others of you will be able to recreate it after this demo. And so now we're going to have a look at some actual code to see how individual DataSHIELD commands work. So first of all, we've got this very useful R package called DevTools already installed on this R session that's running in the server. So we're just going to check what packages are already loaded in. So in this case, we can read DS Base Client is installed, DSI is installed, and DS Opal is installed. That's really good because that's the three packages that are absolutely required to do in a DataSHIELD analysis. If they aren't for you, if you don't get that printout, then these install.packages commands can be used to get them into your system. We're not going to do that because it takes some time and it's not necessary for us in this case. So instead, we're just going to library, which obviously brings the packages into the current R session. And now just that second DevTool session info would print out if you'd had to install the packages. And then we get on to writing the login script. So login script is very important because it's actually forming that DataSHIELD connection that was shown in the animation. So what you will need is the login data frame. So the login data frame will contain lots of different bits of information about the servers you're connecting to. So I've just created these names for various institutions that we work closely with at DataSHIELD. So UMCG, Imperial College London, and Newcastle University. Each of them will have a web URL. In this case, of course, as Shuang pointed out, this is pointing at an IP address that is contained within our virtual machine that's running, because it's simultaneously acting as a server for us. You will have to have a username and a password to be able to access the data. You'll be provided them by your administrator who's in charge of connections to that particular data. And then you will need the name of the data you're connecting to. In our case, it's called CNSIM, which is basically some simulated medical data, which, since it's simulated, it's not going to be revealing any actual person's data, but it's useful because it's quite similar. We'll be looking at various medical statistics, possibly similar to what you'd be doing in real life.
Alex.
Yes.
Can you add the link for the Rstudio on the chat, please?
Sure. So this, I'm going to put two things in the chat. The first thing is the link to the wiki page. The chat's not appearing for me. Chat. I don't know what's going on. Not really sure why the chat isn't. Oh, there it is. So that's the link to all the information about the virtual machine. And then that's the link to the Rstudio server. Oh. Yeah. There we go. That should be both things, is it, Dimitri?
Yeah.
Cool, thank you. So back to the web browser with the Rstudio server in it. So using this builder and builder append, so you can just copy this chunk of code to create your own, unless your administrator provides it to you. And then login data will actually create the data frame, which is all of these appended things added together. And then that login data is sent over the DataSHIELD internet connection using this DSI DataSHIELD login command. So this is the key command that gets you connected to the data you're trying to study. So I'll run that, and I'll run that. We're getting a warning here that it advises a secure HTTP connection, but since it's a virtual machine on our own computer, it doesn't matter here. Hopefully, if in the real life deployment, you would get an HTTPS connection. So let's just have a look at the printout from that connection. We have got a confirmation, a loading bar, and then a confirmation that we've successfully logged into each server, and that all tables in the servers have been assigned and are ready for us to study. Are there any questions building up, Dimitri, that need to be answered urgently?
I'm not sure if people still have any problem with opening the link for the Rstudio.
So you would have a problem opening that link if you haven't downloaded, imported, configured, and then booted the virtual machine. But if you haven't done all of that, then do come back after this session is over, and once it's running, then you will be able to follow that link to get to the Rstudio server. It's a local thing, so it will only work if you've got the virtual machine working on your machine locally. We are looking at other techniques.
Sorry, in terms of the connection, you said HTTP is the one that you're using now, but DataSHIELD is able to figure into using HTTPS.
It is. I don't have too many more details about that myself, but if you have any more technical questions about how that works, feel free to put it in the chat and we'll get an answer to you from an expert on the team. Yeah. Any other questions before I continue? Right.
Sorry, it's been asked a couple of times. What are the necessary network settings for the VM? Sorry, missed that at the beginning.
So this is configuring your VM, you would like to know?
Yeah. So
once
yeah,
you've got
adapter 1, yeah.
Once you've got it imported, then you left click on it so it's highlighted blue, and then go into this orange settings cog. And then once that smaller window is open, then you go down to network, and then just check these two. So 1 is NAT and 2 is host only adapter, and then click OK. And that makes sure on your system everything's configured, because sometimes it doesn't, so it's a necessary step. The second thing that I showed was go again, once you have the thing left click highlighted, go to File in the top left, and then to Host Network Manager. And then does it look like this for you?
Yep.
So if you haven't got anything, if it's just blank, you'll have to create one and then call it these things. So if you want to quickly take a screenshot of this.
Yeah, thanks.
Brilliant. So hopefully with that, you should be able, once it's been done, you should be able to boot your VM and then catch up to where I am at.
Okay, thanks.
Yeah. Any other questions?
Hi, Alex. There's a question in the chat from Lucia Gonzalez, who says the VM takes too long to import the image, more than an hour. Is that normal?
That's not normal. Is Stuart still here, or is Stuart had to leave? I can't see the participants. But I would say that taking more than an hour to import is definitely not normal. It takes me about 3 to 4 minutes.
There's also another question in from Hector. If you can read the chat, it says, failed to save the settings, empty or null host only interface name is not valid. And then there are some error messages.
Unfortunately, I've never heard of that one before. So I will have to have a conversation with Stuart, and I can get back to you, Hector, with some more detailed advice, because I certainly don't know what. Yeah, I'm not too sure about Mac because I don't use it myself. There's someone on our team who uses Mac, so if you don't mind me emailing you an answer, maybe tomorrow, that might be a solution. Right, okay, so back to it. So now that hopefully, after an appropriate amount of time, you have got connected. Then we'll have a look at some commands that run through DataSHIELD. So the Opal web portal is one way of looking at the data. So in our case, we have a particular IP address to go to. That is also in the, I need to wait for that to disappear. There we go. This is also in the Workshop VM's wiki page, which I put in the chat earlier. So we've got an Opal connection, so 192.168.56.150. So we'll go to that. And this is the Opal portal. So this is a website that gives you some information about the data. And if you're an administrator, it allows you to manage the data. But you won't be able to run commands on it like get its mean or anything like that. So, but we are going to have a look at this data first of all. So we're going to use a standard account to log in here. So username is user. And then the password is password. And then we'll sign in. Chrome doesn't like that password for obvious reasons. So what we would do is go to inside the dashboard of the Opal portal is go to projects. And then we are interested in CNSIM. We see here another data set that would be available to study on this virtual machine server. But for now, CNSIM. And once you're on the dashboard of the particular data, then you can go to the table. And each one is a different CSV file. We'll look at the one on the first server, so that's CNSIM1. And here we've got a description of each of the variables. So that's the variable name as we're going to have to address it using our commands, but this is what it actually means in English. So lab TSC will mean in medical terms total serum cholesterol. This is also some interesting information, whether it's a decimal or integer, in this case Boolean. We'll be referring back to this later because different commands need to be run on different kinds of data. For example, a categorical table would need to be run on an integer type variable, or mean would need to be run on a decimal type variable. So back to our Rstudio Server. So here is our first actual DataSHIELD command. So we've got to that stage. So ds.dim. So every DataSHIELD function is prefixed with ds dot, so DataSHIELD. And then the bit after the dot is the actual name of the function. So dim here, it's like the regular dim in R, which is for dimension. Just something I'm going to quickly show you is if you don't know what dsdim is, there's always the help function. Every DataSHIELD function comes with a help function. So if you run it like that, I'm going to do Control Enter to just run that line. And the help is generated here. So as you'd expect with an R help function, you get a description, a usage, arguments, details, etc. We've even got examples for quite a lot of the latest DataSHIELD functions in case you want to actually have something that you know works and then customize it from there. So in the case of dsdim, we're going to run that whole block. And then because this is our markdown worksheet, we're going to have the results printed out here as well as in the console. So the dimensions of this of these data. So all three servers have 11 columns, but on the first one it has 2100 rows, then 3000, then 4100. And then the final line is the combined studies. So it adds all the rows together and gives us 9,300 approximately. Then this is the printout from the second function. So the second function I asked for was column names. Some syntax within the function in DataSHIELD. It asks you what data frame you're connecting to. So D here, that's what we decided to call the whole data frame in this part of the connections command. So you could call it A or B or C, whatever you want, but then you'd have to match that throughout your commands. And the convention we have inside DataSHIELD is to have D. So that's what you'll see in all of the help materials in general. Second part, data sources connections, that's referring to the local object, the local connection object. And it's best to include that just for clarity. So what if we focus on a particular variable and investigate that and do all sorts of things with it? So what is Lab Hdl? Well, you can check back to the Opal Portal. Again, just a reminder, you can get to that through the wiki page about this virtual machine image. And so checking on the Opal Portal, Lab Hdl is HDL cholesterol. So what's its class? What's its length? What's its mean? So I'm going to run the current chunk and we're going to get 3 different printouts. This red text indicates that it's communicating with the server. So that's a good sign. If you got something wrong in the object you're connecting to, it might connect to the server and then show an error. But in this case, we've successfully printed out some results. So thankfully, in all 3 of the studies, it is a numeric variable. Then we've asked for the length of the object. So length is the number of rows, so 2,100, 3,000, 4,100. That matches what we found in the dimension, so that's a good confirmation. And then the third command was mean. So what's the mean of HDL cholesterol? This is a useful table printout of the means in each of the studies we have connected to. So 1.57 in the first one, then 1.56, and then 1.57 again in the last one. Gives you some additional information about the number of missing variables, number of valid variables, so non-missing, and the total number of the last 2 added together. This is another part of the printout which mentions that it was a valid analysis. There wasn't any disclosure discovered, and no disclosure to alert us, the user, to. I will skip this. This is just an example of how to compare mean with quantile mean and do create the help function for it for yourself to work out how to use it. You can do that in your own time. We will, however, have a look at variance. By the way, to the questions, I will be stopping at tables, so don't worry, I will get to them soon. So ds.var, as long as we know that that is the DataSHIELD function we're going for, we can summon the help for it. So let's do that by clicking run chunk. So as you'd expect with a function with VAR in it, it computes the variance. So you will compute the variance of the object you specify using x equals. So using this, if we want to look at the object $lab Hdl, so as you'd expect, accessing a data frame, you use the dollar notation to look inside the data frame and looking at the column which has the name in our lab Hdl. And then this type equals split, what does that do? Well, check across here. and it tells us whether we will split the data or combine the data. So in this case, we want to see variance study by study instead of all aggregated together. Data sources connections as per usual, because that's what we specified at the start. So let's run this, which has the variable specified, and we'll see that it varies very slightly study to study. So the first study having slightly lower variance, but altogether pretty similar. Again, this column here will let us verify. I recognize those numbers from before, so the number of rows in each case looks correct. So what if we had these variances and means, but we wanted to do some calculations with them at in the local R session? Well, you can assign any of these returned objects to local objects. So if we wanted to assign the particular table with the variance printouts, then you can do A and then assign to that A the results. But then I'll have a look at the first object of the results. Just a note to use these double square brackets because R recognizes this printout as a list. So if I run that and then A, I'll run the whole thing. So A printed out is just this table here without the validity message part. So that's not quite good enough. Instead, we will look inside A and we'll call B looking inside the first object and then looking at the first row, first column. So first row, first column is 1.7079, 1.07079. So that's how to isolate it. If you wanted to look at the third row, third column, you'd do 3, 3. So that is the end of the summary statistics part. Have we got any further questions?
There are a few questions about, there are some people that still have problems with virtual machines. I'm not able to help them. The only thing that I can say, if you basically we are using VirtualBox and virtual machines for these workshops, but in a real analysis setting, you don't have to worry about that because you just need to have some credentials on how you can log into the servers. And Stuart is not here to help you now on using these VMs, so sorry about that. Do you know, Alex, if there is a limit in the RAM that they need to use the VM?
I'm afraid not. No, I don't know.
Yeah.
But we will have a log of these questions, and any we don't know, we will be able to put to Stuart after this session, and hopefully email to you or provide in a public space where you'll be able to see. Are there any others?
I think not for now.
Okay, thank you. So I'm not going to show you tables, as that occurred in the December DataSHIELD workshop, which is already published on YouTube. So there is a recording of that here. I'll put that in chat quickly in case you don't have access to this. Chat. Gonna come this time. Well, maybe when I've stopped presenting, it might decide to. Can't summon it, sorry. Anyway. Yeah, that'll be on our YouTube channel anyway. And I'll put that in the chat later. But you are able to see if you've managed to get the virtual machine running and the Rstudio Server session running. There is this other R Markdown script where there is some more discussion of tables. So assign type functions. So what are those? What we've seen up until now are aggregate type functions. So in DataSHIELD terminology, an aggregate function is one that brings results back to the user. But in some situations, that is not allowed. It may be that the result of the calculation you're trying to perform is extremely disclosive, and therefore you can't, it would be wrong for you to be shown that statistic. But what if it's still important to do a calculation? Well, then you can do a calculation without seeing its result, which is what we call assign type functions. So an example would be if you want to take the logs of lots of values on the server, then there's this calculation ds.log, which will take the logged values of the vector you're looking at, so that x equals part, and it will create a new object on the server's R session, and you can specify its name using this argument new obj. Each function will have this new object argument. You'll just have to check the help function for the specific syntax. And then while you won't be able to look at the logged values, you will be able to then go on and do further calculations with them. So let's run this code chunk here. So we're going to do ls, which lists the objects on the data server, and then create the logged values vector, and then list the objects on the server again afterwards. So beforehand, we've got D on each of the servers. And then we create this assigned thing here. That's confirmation that the assign type function dslog has run. And then we've run the ls again and found that on each server we not only have D, which is the original data frame, but also this new vector lab_hdl_log. So that is one confirmation that the new object has been created, but it could have created any old thing. What's the mean of those values? Well, we've run ds.mean and found that the mean values are 0.4, 0.39, 0.41. So comparing to what we got before of around 1.56, that seems about right to me. Yeah, that's the printout of the actual means again. So you can infer some things like that without actually viewing the newly created object or the manipulated or calculated object. So what other assign type functions have we got going on in DataSHIELD? Well, there are lots, but I've just used 4 examples in this case. Sorry, not 4. But anyway, there's the square root command, which is an assign type function. So it will take a vector within our data frame D, and we'll perform a square root on it, and then we'll create a new object. Here I'm calling Lab Hdl _ sqrt. So we'll run those 2 and see what gets created. So now, this is the output of the assign type function. It's telling us it has worked, it has successfully assigned, but not telling us the actual values, of course. And then the results of the ds.ls, so the list of the server-side objects. We now have the square root object on all 3 servers successfully created. And then this dsmean, if you want to run in your own time, that will also confirm that the various magnitudes look about right. There's another kind of assign type function where you can do lots of other kind of calculations, such as add a value to every single element of the vector, or subtract and divide by a number, and that is dsmake. So if we use the help for that, that would be the various arguments you'd use in that case. All right. So, any further questions before I go on to my part of subsetting? No? Okay. So the subsetting chapter, I will present you the first bit of it, and then I'll hand you over to Dimitri to continue, and then from then to the end, after which we will open up into questions. So subsetting. This is something we thought was quite important to show you because it expands the scope of what you can do with the data that is available to you. So you don't just have to look at a whole large data frame. You can cut it down to just the elements you are particularly interested in. So some examples that are going to be shown here by me. So I will subset a column of data by its R class, subset a data frame to remove NAs, and subset using a Boolean inequality. And then I believe Dimitri has a more complicated example of using Boolean inequalities to subset much more finely. So, which column name do we want to look at in this case? That's the column names aggregate type function. So that's the list of them. That's just the same as we saw on the Opal portal. So we'll want to have a look at gender in this case for the purposes of this example. So we'll do the levels of gender. And because it is an integer type variable, then it will have the variable, it will have the levels, pardon me, 0 and 1. And then we will use the Boolean operator part of the data frame subset DataSHIELD command to force it to create a new object cnsim subset males by doing exactly equal to 1 for the gender variable, and then create a new object cnsim subset females by having the Boolean operator must equal to 0 on the $gender column. And if I run all of that, going quite slowly. Slowly, but it does seem to have successfully created, I think. Yes. So we get this validity check for this function as well, just assuring us that we have created the object and it appears valid and hasn't run into errors. So another thing we can do is remove NAs from a vector. If NAs would upset your calculation, then you can remove them by using the DataSHIELD complete cases command. So ds.complete cases. Just going to note here that capitalization is quite important. If you mistakenly put all in lowercase, this wouldn't be recognized. So do study the help functions carefully for how to format your commands to make sure they succeed. So in this case, yeah, D without NA is going to be the object's name. I'm going to run that and it's going to be created. So subsetting with an inequality. This again is using a Boolean operator greater than or equal to. So this is part of the DataSHIELD data frame subset command. Note the capitals here, the beginning of each. So the data frame name we're looking at is D. The first column we are looking at is the continuous BMI measure, and then the second argument is the number 25. So it's saying when is BMI continuous greater than 25. It will check every single column. No, sorry, it will check every single entry of that vector and take out the ones where the inequality has been satisfied and create this new object, BMI 25 plus. So again, it might take a little bit of time because it's checking through all of the column. So we have the confirmation that it's worked. And this time I'm just going to verify what we've created by doing a quantile mean and a histogram of it. Of the new object, that is. So the graph itself looks really good. So the very lower end of the new objects is 25. So if we compared that to a histogram of the entire thing, you'd see that it has changed to be only 25 and higher. The R console contains the quantile mean command, so that's going to have the quantiles of the new object. So we see the fifth percentile is 25.35. Good to point out here that obviously we can't have the lower bound because the lower bound is an actual patient's result, and therefore that would be disclosive. So we'll only operate in DataSHIELD in terms of intermediate percentiles that won't give anything away and be disclosive. So that is my part all finished, and I'll hand over to Dimitri so he can do subsetting with multiple conditions and then graphs and possibly modeling after that. Dimitri, would you like to share your own screen for this bit?
Yeah.
Yeah, I'll stop my share here.
Can you see my screen?
I can, yeah.
Okay, are there any questions for the first part? Okay, we can answer any questions later. So the next way that I will show you on how you can make subsets depends on multiple conditions is with using a function that we call DSBool. And this function creates some dummy variables, which can be used then to combine multiple conditions, or in some other cases, you can, if you want in a regression to create some dummy variables for some specific reasons, you can also use the same function. So what we want to do in this example, we have our original data frame, and we want to create a subset for all the individuals that have BMI greater or equal to 25, and the adjusted glucose level is lower than 6. So how we can do that, because the data frame subset function and allow you only to have a single condition at each time you use the function. So what you can do for this example, if you have multiple conditions, you can either use the data frame subset many times, in that case 2 times, or this is another trick that you can use using the DSBool function. And what we are doing here in the first part, in the first use of DSBool, we say create a vector in each server, where this vector includes either true or false, or zeros and ones. And it says that if BMI is greater or equal to 25, put in that specific cell for that individual true, or in that case, because we say numeric output equal to true, it will put in each correct condition 1, and if the condition is false, it will put 0. So this is the first use of the DSBool. And then we use the same thing, but for the second condition. We say that create a new vector in each server, and this new vector includes ones if an individual has glucose lower than 6, or 0 if an individual has glucose level more or equal to 6. And if we create these 2 new vectors, we can then use the DSMake function. This is another assign function that Alex mentioned before. And you can do any type of calculations you want, assigning new objects on each server. So what we are going to do now, we create 2 new vectors, and we want to add up those 2. We create the sum of both vectors in each server. So what it means that we create the sum of those 2, it means that in the cases that both conditions are correct, the sum of those 2 vectors is equal to 2. If one of the conditions is correct and the other one is false, then the sum of the 2 is 1. And if both conditions are wrong, the sum of those vectors is 0. So we create this new vector, which is assigned to each server. So the user doesn't see anything in the client side, but we call this new vector as BMI 25 plus. You can use any type of name that you want. And then we can create a table just to see how many observations we have in each of these 3 categories. We have the category where both conditions are correct, the category where one condition is correct and the other one is false, and the category where both conditions are wrong. So by the way, I ran everything before the workshop. So in each block of code, you can click run, and I can explain you what the results are. So the first 2 cases is where the server, the DSBool function assigns the vector to the servers. The third outcome here, it says that the DSMake function assigns the sum of the 2 vectors in the server. And then we create the table. And as you can see, the outcome of this table includes many information, includes the row percentages, the column percentages, and here is the actual table that where we can see the counts. So as we can see, the category that we are interested in includes 550 individuals in the first study, 833 individuals in the second study, and 1,051 individuals in the third study. So we have created this new column, which has these categories, and the category equal to 2 is what we want to use because it means that both conditions that we want are correct. And what we can do next, because all the assigned functions create, and this was a question on the chat, if you use an assign function, it generates an object on each server. So in that case, because we are creating a vector, this vector is not included as a column in our original data frame. But if we want to add it as a column in our original data frame, we need to use the data frame, either the DS data frame function or the DS SymBind. Both functions do the same. So what we say here, we say use the original data frame and just add one new column, which this new column is the vector that we created earlier. So as you can see, we can create the new data frame. We call it D2. And if we look now the call names, you will see that we have a new column, which is the vector that we created earlier. All the other variables were included in the original data frame. So now we have the new data frame, including this dummy variable. And having this new data frame, we can create a subset where we say if BMI 25 plus glucose 6 less is equal. So now we use this Boolean operator equal to 2, then create a subset with only those cases. And if we do the dimension of this subset, we can see that has the correct dimensions. We have 550 individuals. This is what we observed in the table before for the first study. For the second study, we have 833 individuals. And for the third study, we have 1,051 individuals. So this is just to show you how you can use the dsBool function, which is quite useful in different cases, not only for subsetting. So the next section is about graphs. So the graphical functions in DataSHIELD are the only functions that are somehow different than all the other functions. All the other functions in DataSHIELD are dealing with the actual data, but the graphical functions, because they return some data points back to the client, they use some type of anonymization techniques. So what is returned back is slightly different values, but this is only true for the graphical functions. Okay, so the first graphical function that we can see here is the Nds histogram. So you can create the histogram of any continuous variable, and we can see the distribution. And we can also do Nds histogram for the combined analysis. So we can see the histogram of the same variable, but across all the 3 studies. So if you put here just type equal to combine, you will see the one histogram that is the pooled histogram. I'm not sure if I can run this or, yeah. Oh no, because I have to reconnect again to my VM. But if you do it in your machine, you will see one histogram. The next function is the Dscatter Plot. So if you want to create a scatter plot for 2 continuous variables, you can use this function. Again, you can use type equal to split, which is the default argument. So you can see a separate scatter plot for each study, or you can set the argument type equal to combine, and you can see only one pooled scatter plot. So this is the reason that I told you that we use some anonymization techniques, is because if we return the scatter plot back to the analyst, each point in this plot has some coordinates, which are the values of these two variables. So in order to avoid returning the actual values back to the analyst, we somehow change the points, but we keep the association or the relationship between any two variables the same as the actual data. If you want to have a look in more details on what type of methods we use in the graphical functions, I put a link on a recently published paper that we published in the EPJ in Data Science, and you can have a look on more details. So, and then we have 3 other graphical functions in the current version of DataSHIELD, so you can have a look later on. It's about heat map plots, contour plots, and box plots. Another thing that you can do with graphical functions, and I'm going to show you in the next section. Do you have any questions about the graphical functions? Okay, we can have a question section later. The next section about the regression models. Here I will show you 2 simple examples, one with simple linear regression where we have only one explanatory variable, and another one with a more complicated model. But in reality, you can do more complex analysis like generalized mixed models. You can do survival analysis with piecewise exponential regression. You can do regression with interactions. You can do logistic regression and more complicated stuff. And another thing that I want to mention here is that in DataSHIELD, we have 2 types of analysis for regression. We have the study level meta-analysis, which means that if we have a regression model, we feed this regression model to each study separately. We get the final results from each study back to the client, and we meta-analyze the final results, and we create a pool table of the results. This is the first way to do regression. The second way is what we called either individual partitioning data analysis, or in some cases we call it virtual pooling, because it means that we get the same results as if we allow to pool all the data from multiple studies together in one central warehouse and do the analysis there in only one warehouse, we can get exactly the same results as in our virtual pooling method. So here I will show you both. So for the first example, because in this fake data that we use for this tutorial, we don't have big associations between any pair of variables, I will show you an example where we want to predict the level of triglycerides using the BMI variable. So if we just see the correlation between these 2 variables, we are going to see that they have, this is the correlation matrix, and what we have in the non-diagonal elements of this matrix is the pairwise correlation between BMI and this variable. So as you can see, we don't have a strong correlation, but we are going to use these 2 variables in a regression model anyway. And this is the scatter plot. Again, you can see that we don't have a strong relationship, but we are going to use, going to run this regression model. So how we use the DSGLM function in DataSHIELD is the same way as we do it in R. In R, you might use the GLM function before. So the way that we use it, inside code marks, we put the regression model. On the left-hand side of the regression model, we put the outcome variable. And on the other side of the model, we put all the explanatory variables as a sum. So here, in this example, we have only one explanatory variable. And by default, the model includes an intercept. Then the next argument, we need to define the then distribution of the outcome variable. In that case, because we have a continuous variable, the family is Gaussian. And if we run this model, we can see a lot of information here, but what we are interested more, it's about the regression outcome. The outcomes is the estimate coefficients, standard errors, and p-values, just to say if these variables are statistically significant or not. So these are the pooled outcome. So we run a regression, run across all the connections that we have. We have 3 studies, and what we get back are the outcome of the regression across all studies. This is the method that I told you that we usually called virtual pooling. You can do the same thing with GLM SLMA. SLMA stands for study level meta-analysis. So in that way, you have the same type of formula, you have the same family. This is an argument that you can use if you want to save your object in each server, but it's optional. And as you can see, the outcome of this GLM SLMA includes the regression outcome for each study separately. So if we go down here, you can see that we have the covariance matrix from study 1, the variance covariance matrix from study 1. We have the regression estimate, the regression coefficients from study 1, standard errors, p-values. Then we have the same information for study 2. Then we have the same information for study 3. And at the bottom of the outcome, you can see that we have also here, we have the meta-analyzed outcome. So this is done on the client side. And as you can see, the regression coefficients, the estimates, are close to what we had before. It's 0.22 and 0.08 in the SLMA approach. And if we go back to the virtual pooling approach, you can see that we have almost the same estimates. So you can use any type of approaches you want for your study. And what we can do next for these regression outcomes, for the SLMA approach, we have the new function that we call Glm Predict. And what this function does, assigns the predicted values in each server. So because the predicted values and the residuals are disclosive to return back to the analyst, we blocked this to be returned back. So if you look on the outcome here, you don't see the residuals or the fitted values that you can see in native R. This is blocked in DataSHIELD. But what you can do instead, you can save these predicted values in each server and use those for some other reasons. You can do regression plot diagnostics, or you can do anything you want using those on each server. So what we are doing here, we save the predicted values in each server, and we call this new object that is saved prediction object. Another thing that I want to mention here is the regression in R, in native R, and also in DataSHIELD is run in the complete cases of the variables that you have in the model. So in that case that we have only 2 variables, the function takes only the pairwise complete cases. So if you do the length of the fitted values that we created and the length of the actual outcome variable, you will see differences in the length. If we go down here, initially, for example, in the first study, we have 2,163 observations for that variable. But for the fitted values, you can see that we are down to 1,730. And this is because the GLM model is run on the complete cases. So what we can do, we can just combine these 2 variables that we have in our regression model together, create a new data frame called vars, and then use the complete cases function that Alex showed before to just remove any rows with missing values. And if you do the dimensions of this new data frame now, you will see that we have the correct dimensions as we see in the length of the fitted values of the regression. So in the first study, we have 1,730 observations. And as you can see here, we have the same length, and the same for the other two studies. The other thing that you can do by saving the fitted values in each server is to make some regression plot diagnostics. So this is an argument that I want to show you in the scatter plot function. The way that we used the scatter plot function earlier, we didn't use this argument at the end. So if you just use the two variables that we're going to use to make a plot and the data sources that we want to use, we just observe the outcome scatter plot. But if you put return coordinates equal to true, the DataSHIELD return back to your R console the coordinates of each data point in the plot. And then if you assign these coordinates with a name, you can use it in your analysis computer and do whatever you want. And we allow to do that because we think that you can use those coordinates and use any type of graphical functions in native R. For example, you can use the ggplot and make your graphics more stylistic better. So you can change colors, fonts, anything. But here, the specific reason that we use the return coordinates equal to true here is because we want to display in the same plot the original data points and also the best fit that we get from the regression. So if you run this block of code, the part here is in native R. Nothing is done with DataSHIELD. So you can do whatever you want here. You can change the axis labels, the titles, whatever you want, you can do it in native R. And we can see here that we have the original data points, which, if I remember that I told you, are slightly anonymized, and then the best fit for each study. For the virtual pooling, so here, if we go in this line, this is a typo that I did. Here should be, instead of SLMA, should be individual partition data approach or virtual pooling. In the virtual pooling, because we don't have a similar function as the Glm Predict as we have here, we can create the fitted values in each server manually. And how we can do that? We can do it using the Nds function. We used the Nds function before to sum up two vectors, or we can use it here to create the fitted values, the predicted values from our simple linear regression. And what we have here is the estimated intercept. This is the outcome of our regression model. The slope is the estimated slope. And then we have the explanatory variable, in that case is BMI, but we use the BMI from the complete cases because I told you before that GLM runs on the complete cases. And if we run this code here, we assign in each server a vector which includes the predicted values. We can do similar way to create the residuals. So the residuals is just the difference between the outcome variable minus the predicted values. I told you before that these two objects are not returned back to the client because are disclosive. Anyone can make, if we return those two back, anyone can make the difference and get back the actual outcome variable. So this is the reason that we block the return of those two back to the client. But in that way, you can create those in each. You can create those in each server, and then you can use again the scatter plot.
You know,
Now, in this case, we can use the scatter plot to do some regression plot diagnostics. So in this example, I plot the predicted values versus the residuals. And this is a way where you can check if the assumptions of linearity is valid in your case, or you can check homoscedasticity and some other assumptions. Or we can do the histogram of residuals and check the assumptions that our error terms follow the normal distribution and if they have mean equal to 0. And as I said before, we can do more complicated regression. This is a way that you have here a logistic regression. The outcome here is a binary variable. So if you want to run a logistic regression, you need to use the binomial family. The outcomes in binary. And also here in this example, we have an interaction term. It's an interaction of a continuous variable versus gender. And the interaction is symbolized by this star also in normal R and is the same in DataSHIELD. And you can do again this complex regression model in both ways, either in IPD, so we use the Nds function, or in study level meta-analysis. And if we assign the outcome of this function, by assign I mean that we have a name here, and we use this equal symbol in R, which means that if we do that, we don't observe an outcome here, we just see the process of the function, but we can use the name later and get the outcome. So if you type again the name, you will see the outcome, and from this outcome, we want only the estimate coefficients. And from this SLMA, the same. And if you compare these two, the first table here is the outcome of the IPD approach, and the second table here is the outcome of the SLMA. As you can see, the estimates are close to each other. For the intercept, we have -6.42. Here we have -6.45, and all the other outcomes are similar. Okay, so this is about regression analysis. And the last thing that I want to show you before going to question section, every time that you finish your analysis, because you are going to use a central analysis compute server in your consortium, in Athlete, or if you are a member of another consortium, usually it's better if you log out from your session. So to log out, you use this function here. But before you log out, if you want to use what you created in the next time that you log in, you can save your workspace, so you don't have to rerun everything from the beginning. And how you save your workspace, you can use this function from DSI package, which is called datashield.workspace_save. You define the name of your connections, and you write the name of your workspace. And then when you save it, you can log out. So if you save it, you can log out. Now, if we log in back in the way that Alex showed you, where we log into the original data using the original data frames and do DSLS. DSLS is the function that shows what objects we have in each environment. You can see that if you just log in with the normal way, we have only the original data frame in each server. But if you log out again and use again the DataSHIELD login function and say restore the workspace that we saved earlier, you can see that we have all the objects that we created earlier. So you don't have to rerun the whole script, but you can start from the point that you saved the workspace. And there are a few other functions about that. we have in DataSHIELD.workspace where you can see how many workspaces you have, or we have in DataSHIELD.workspace_remove where you can remove any unwanted workspaces. But these two functions are important. You need, if you want to save your workspace, you need to use this. And it's better if you close your session after you finish with your analysis. So I think that's it. And we can go to a question session. I will stop sharing my screen.
Okay, Dimitri, I've got 2 noted down from the chat, but I'm sure more may appear. So for now, one of the questions was about the subsetting topic. Will subsetting always produce a data frame as an object, or will it sometimes be creating a vector object?
Always, if you want to create a subset from a vector, it will create a vector object. If you want to create a subset from a data frame, it will create a data frame object. I don't know if we can use the data frame subset for a vector. But for example, if you want to use the complete cases function, you can do it for a vector. Let's say that you have genter, and genter variable include missings. You can then use the complete cases and create a new vector of genter, which excludes the missing values. So in that case, it's a vector. But usually, the common use of DS data frame subset, it's for data frames.
Yeah. And then the next question I noted down was from the linear regression section. So the standard errors printed out in those tables, are they robust standard errors?
Yes, in both cases, in IPND and basically what is returned by DataSHIELD is the same as you get in the GLM function in R. But if you are applying logistic regression, you have to make the transformation of the standard errors and the coefficients.
Yeah. So we have a question from Christina. It says, for how long would your workspace be stored on the server side? Would this be up to this server administrator?
Yeah, I'm not sure if because if for example a consortium has, let's say, 100 users, and each one saves their workspace on each server, these take some memory, and in some cases it's better if each user don't have more than one workspaces. But I'm not sure if the data managers of each server keep the workspace for a specific time frame and delete it after that. This is something that the data managers should answer, and I don't know. But in reality, you can have it forever if the server is run and has space.
Yeah. All right. Are there any more questions?
If you have any more questions, if you think anything later, you are free to contact us either in the DataSHIELD forum or in DataSHIELD email. Yeah, I think we have these two channels, and also we have a lot of information in our wiki and in our website.
I'll just get the homepage of the wiki and put it in the chat as a link.
Yeah, but we still have time if there are more questions.
Yes.
Can we just directly ask by this, or do we need to type it in the chat?
About Do you have a specific question in the
Yes.
chat?
So about the server administrator. So from the server administrator's perspective, we're really curious about where do you save this workspace? Because we don't want the workspace to be saved in the original data structure database. And
yeah, okay, basically, the original data are never changed because each time a user log into the data, it's like the server creates a copy for that user. So the original data never changed. Even if you if you say delete the original data frame D, the data frame doesn't delete. It's always stable. But if you, let me check if I can share my VM. Just a second.
so basically, for every user, you copy the data from the original database into a R data frame, and each subsetting of the data, you create a new data frame, and all the data frame is stored in this workspace for that user.
Yes. And this is the reason that you can allow multiple users to run analysis on the same data at the same time, because each user has its own copy and its own workspace. And even if two users use the same username and password, which in some cases is not good, but even if you allow to do that, each user, even if they use the same username, they have their own workspace. And they can do different analysis at the same time. I'm trying to see in my VM where the workspaces are saved, but I can't find it. I'm not sure if we have this information in the wiki. Do you remember, Alex? If, for example, if a data manager has access to the Opal interface, can he see how many workspaces are saved and how can remove one?
I'm not sure I know the answer to that. No. So perhaps if you email that question to the DataSHIELD inbox, then we will get the right person to answer that for you.
Yeah, I'm not sure either, but we can find this information.
It's fine. I think it's from our perspective, I am from the Safe Haven in Scotland, and I think we talked with your colleagues on collaboration of setting up DataSHIELD within the Safe Haven. That's going to be a question going to be answered by the work itself. So
yeah, okay. Okay. For which project are you working for?
we haven't started a project with you guys yet, but
Okay.
we've been in this initial contact with you guys, talking about using DataSHIELD to conduct some demonstration analysis on the NHS data that we have.
Okay. Yeah, we can speak in another stage and help you with that.
Yeah,
another thing that I want to say, it's somehow related to what you said about it's about harmonization, but I got another question in a private here, and say if you want to run a regression model where some variables are in one data in one server and some other variables are in another server. That's not possible. Basically, we have two versions of DataSHIELD. The version that we called horizontal partitioning DataSHIELD, which means that you have multiple servers. Each server includes the same variables, but for different individuals. So this is the reason that we call horizontal partitioning. And in that case, you can use what I show you in this tutorial. And then we have the vertical DataSHIELD, which means that you have, if you have, let's say, two servers, these two servers can include the same different variables, but for the same individuals. And in that case, you can make record the linkage, for example, if they share the same IDs. But this is not implemented yet in DataSHIELD. You are not able to do that yet. We have a proof of principle for regression models, but it's not implemented yet. The thing that you can do is if you have multiple tables in the same server. For example, if you can have a server, let's say with exposome data, with genetic data, with some other data, but for the same individuals, then you can use DataSHIELD functions to merge these three or more tables together. Or even you can keep it separate and run regression where different variables are in different tables. So that's possible. But what I told you as vertical partitioning is not possible yet. I'm not sure if you have any other questions.
I haven't seen any in the chat yet.
Yeah, and the other thing that I want to say again, it's about the installing the virtual machine at the beginning of this tutorial. It's quite difficult. In some cases, you have these errors, but in a real analysis setting, you don't have to do that. You just need to log into the servers using credentials that you will get from the data managers of each server. And then you just need to run your own script with DataSHIELD functions.
Should we give it 5 more minutes for people to have time to think of any further questions? And then...
Yeah, and you can send us email with anything you want, any questions. Yes, you don't need the virtual machine for the real analysis.
So just to add to that, in place of the virtual machine in this example, you would be connecting to an actual server somewhere else in the world via the internet. And that would be hosting the data for you. This is just a simulation of that.
Actually, in terms of setting up the server, do you think that will be a major task? How easy it is to set up a DataSHIELD server? Do you have a Docker container for that? Or
Yes, but not if you are going to use Opal. Can I ask Stuart to contact you after that? Because we can use Docker. There are some settings where they use Docker, but I will ask Stuart to contact you with more details. If you want to set up a server using Opal, there is an Opal wiki with all the details. But if you want to use a Docker, I will ask Stuart to contact you.
Cool, no problem. Thank you very much.
That's the link to the Abiba wiki in the chat.
And another thing that I want to say about the tomorrow's tutorial, Juan is going to demonstrate the resources. It's a new feature in DataSHIELD where you can get access to data in different formats, in different database formats, in different locations. And also, for example, and this is quite useful for big data. You don't have to download this data in an Opal server, but you can just use a secure link. But this is something that Juan is going to show tomorrow. So it will be interesting.